Now in the previous lecture, we have seen the average value of current and RMS value of current. And using that average value and RMS value, we have found out the peak EMF formula and your peak current formula. Using that, now we are going to clear the two terms. One is nothing but the phasor and another is nothing but the phasor diagram. Now what is phasor? You have your current values. We are getting I is equal to I0 sin omega t, and EMF value I am getting E is equal to E0 sin omega t. Means your current varies with sin angle, your EMF varies with sin omega t. So this current value and EMF value changes its direction. So see here, if I draw such sinusoidal wave form of either current or EMF, then what is the thing here? Suppose I am saying it is E or I. Point to point, the direction of your current will goes on changing. So this direction of current changes as your angle will goes on changing. Means your current and EMF vectors, they are rotating vectors, and that rotating vectors of current and EMF are to be called as a phasors. That phasor we can represent in the phasor diagram. So in the phasor diagram is what? I can say that if I am saying this is a current and time interval. So if I draw this vector, suppose this vector I have extended, this small yellow chalk vector, this I have extended from, so it will make certain angle with the time interval, angle theta, which is equal to nothing but omega t, because your vector is rotating with angular velocity omega. From vector I can draw a perpendicular component. So this perpendicular component, this length of this perpendicular component, this is nothing but as that value is nothing but I sin omega t, and intersection on this x-axis, this value is nothing but as your I0 cos omega t. So this is to be called as your phasor diagram. So why it is necessary? Because whenever we are going to apply this AC voltage or AC current to a circuit, that is, if we apply AC current across purely resistive circuit, then what is the EMF in the resistance? What is the current in the resistance? Then using that we can draw the phasor diagram. From phasor diagram I can get the relation between EMF and current. So to understand all that things, there is a necessity to understand what is phasor and what is phasor diagram. Now how it is so comes in the picture. So now I can show you a simple circuit. So all of you are knowing this component. This is called resistance. Across this resistance, if I am going to apply AC EMF, alternating EMF. Alternating EMF E is equal to E0 sin omega t. This is nothing but the alternating EMF. So what I have applied? AC is applied across purely resistive circuit. Only resistance is in the circuit, so it is called as a purely resistive circuit. AC means alternating EMF. So that I have applied here. So this alternating EMF will send the alternating current, and that alternating current will be flowing through this resistance shown by this arrow direction. Clear? So now, what I write? When that alternating current will be flowing through resistance R, E is equal to nothing but I into R according to Ohm's law. So I am getting both the equation. This is the alternating EMF applied across the resistance by AC generator, and this is the EMF produced in the resistance due to alternating current. If your circuit is 100% efficient, then both the EMFs are same. So ideally I can say that both the EMFs are same. So equating your equation 1 and 2, what I write? IR can be written as E0 sin omega. Means current I can be written as E0 upon R sin omega. So E0 upon R, EMF upon resistance, which is nothing but I0. Means what I am getting? Current I is equal to nothing but I0 sin omega. So current flowing through purely resistive circuit is this. And what is EMF across resistive circuit? E is equal to E0 sin omega t. Now just concentrate on both the equations. Current varies with sin omega t. EMF varies with sin omega. Fine? Now, using value of omega t, now I can find out value of current and value of EMF from the chart. So I can formulate one chart. In that chart I can put the value of omega t, that is angle value. First 0, second pi by 2, then pi, then 3 pi by 2 and then 2 pi. Now see here, for I can use current expression. Omega t is 0 means sin 0. Sin 0 is 0 means current is 0. Then omega t is pi. Sin pi by 2 1 means current is I0. Next sin pi 0. So again current is 0. Sin 3 pi by 2, that is minus 1. Minus 1 into I0 means minus I0. And now again sin 2 pi. Sin 2 pi means again 0. Similarly now EMF. Equation is E is equal to E0 sin omega t. Instead of omega t, I can put the value, first angle value 0. So sin of 0 is 0. 0 multiplied by E0 means E value will come 0. Second omega t value is what? Pi by 2. So what I say now? Sin pi by 2 is 1. 1 multiplied by E0 is E0 means next is E0. So like that manner I can get these values. And now concentrate on the table and see here. When your current is 0, at that time your EMF is also 0. When your current is positive peak current, at that same angle your EMF is also, peak EMF is also positive. Here, when your EMF current is negative, for that same angle value, your EMF is also negative. So from that, what we can say that when current is 0 for a one particular angle, for same angle, EMF is also 0. When current is positive, EMF is also positive for that same angle. That's why we are saying that from this observation I can say that current and EMF through purely resistive circuits are always in the same phase, or I can say that they are in phase. Now what is the meaning of that phase? For that meaning of phase, we can plot a graph. Just concentrate here now. I can plot here a graph of EMF versus omega t. 0, pi by 2, pi, 3 pi by 2, 2 pi. Now, pick EMF. Positive is 0. Pick negative EMF. Minus is 0. And now I can start plotting the points. Angle 0 EMF 0. Angle pi by 2, EMF is 0. Pi, EMF 0. 3 pi by 2, EMF minus 0. 2 pi, EMF is 0. And now if I draw a graph, the graph nature is nothing but the sine graph. This is for EMF. Same graph I can plot for the current in the same graph. For 0 angle, current is 0. Then for pi by 2, current is I0. So I can say that positive y-axis plus I0, negative y-axis minus I0. So I will get plus I0 1 here. Again pi by 2, now current is 0. 3 pi by 2, current is minus I0. 2 pi, current is 0. And now if I plot a graph for the current, I am getting such type of graph. And now concentrate here. Your first half cycle in between angle 0 to pi. In this cycle, when EMF is positive, current is also positive. And in the next half cycle, in between angle pi to 2 pi, when your EMF is negative, current is also negative. So current changes its direction along with the direction of EMF. That's why it is to be said that in purely resistive circuit, your EMF and currents are in the same phase or in the phase. Fine? So these are the two very important equations. That is current through resistive circuit when AC is applied and EMF through resistive circuit when AC supply is applied across a resistance. Once I am getting this as a current and EMF, then I can find out here the power in the circuit. Or one more thing I can say here, phase angle difference between EMF and current in purely resistive circuit is 0. So phase angle difference. Phase angle difference, which is denoted by phi, is 0 because both are in the same phase. So phase angle difference is 0. Fine? Or either it is denoted by alpha or it is denoted by letter phi. Now I can find out the power across this circuit. So electric power across this circuit, power P is equal to E into I. E value is known to you, I value is known to you. So I can substitute. Instead of E, I will substitute E0 sin omega t. Instead of I can substitute I0 sin omega t. So its value will be become as a I0 E0 sin square omega t. That is nothing but the power. Right? Now I can find out the average power. So power average is E0 I0 average of sin square omega t. So you have to find out the average of sin square. Clear? So average of sin square omega t. This value you will get it as a, this P average can be written as E0 I0 and average value of sin square omega t is nothing but half. So this same equation, so I am getting first formula, P average is equal to E0 I0 upon 2. Or I can write down P average is equal to E0 upon root 2 into I0 upon root 2. And in the previous lecture we have seen E0 upon root 2 is nothing but your ERMS and I0 upon root 2 is nothing but IRMS. So I am getting this formula for second formula for P average. So this is first formula, this is second formula. This P average is also to be called as apparent power. So either apparent power is a product of ERMS and IRMS. Clear? Any doubt? Okay. Thank you.